Today we're talking about solving absolute value equations. The first thing we have to understand about absolute value equations, or absolute values, is they are always positive. Now, what represents an absolute value is having brackets around something. So, if we see something like this, we have two brackets and a 5. This is read the absolute value of 5 is a positive number, 5. If there's a negative number in there, the absolute value of negative 14 is 14. Again, it's positive. Positive 5, even though it starts positive, it stays positive. It starts negative, it's got to be positive. If we threw a term in there, maybe we have the absolute value of negative 4x. That is just 4x. And then if we have, maybe we have a fraction. The absolute value of negative 7/5 is, again, positive 7/5. These numbers have to be positive. Every single time you see these bars, the answer has to be positive. This is how mathematicians evaluate distance. So we can never have copy this down, a negative distance. Right? Whether I'm going from, say, my house to your house, and it's 4.5 miles. You coming back the other way is still 4.5 miles. We cannot go a negative mileage. We can never go negative time. So that's why we use it to represent this. Now, letter C in the note says, it always has two answers except if the absolute value equals 0. If the absolute value equals 0, we will have one solution. Other than that, if we can solve it, it will have two solutions. We'll talk about problems in class, how we may have no solutions. And then finally, when solving an absolute value, first you must isolate the absolute value before creating your two solutions. So we're going to practice 4 problems and kind of see what all this means. So number 1, we have the absolute value of 2x plus 5 equals 15. Now I look at this, and again, part D says always isolate the absolute value first. This is all by itself. There's nothing being added or subtracted. There's nothing being multiplied. Now we have to create two problems. 2x plus 5 equals the positive answer, and 2x plus 5 equals a negative answer. The 2x plus 5 stays the same. The 15, one's 15, the other one is negative 15. When we solve this, both times we're going to add negative 5. Let's do this first. 2x equals 10, divide by 2, and we end up with 5. In the second problem, we add the negative 5. We end up with 2x equals negative 20. We divide by 2, and we get an answer of negative 10. Now you might wonder, why does this work? How does this work? Well, if we put a 5 in here, 2 times 5 is 10, 10 plus 5 is 15. And again, we know the absolute value of 15 is 15. If we put a negative 10 in here, 2 times negative 10 is negative 20, plus 5 is negative 15. And what's the absolute value of negative 15? Again, it's positive 15. So that's our first example. Problem 2. So again, if you need to stop the video, please stop the video to copy this down. Here's number 2. Absolute value of 4x minus 8 equals 4. Now at this time I would pause the video, complete the problem, and see if you get it right. going to take 4x minus 8 equals 4, and 4x minus 8 equals negative 4. To solve the first problem, and my first answer is 3. My second problem, I'm going to add 8 to both sides. Divide by 4, and I get an answer of 1. So my two answers are positive 3 and a positive 1. We don't necessarily need to have a positive and a negative. We have two positives, or we could have two negatives. Problem 3. (5x minus 3 plus 4 equals 13). Now remember in that part D section in our notes, it says we have to isolate the absolute value by it first before we can make our two problems. This is one of the biggest mistakes students will make. When we do this, we have to get this by itself. So I see a 4 is being added to it, so we have to add opposites first. Now, we end up with the absolute value of 5x minus 3 equals 9. Now we can kind of split this up to make it 5x minus 3 equals 9 and 5x minus 3 equals negative 9. And we solve. Add 3 to both sides. Divide by 5. And we have, leave it as 12 fifths, or if you want to rewrite it as 2.4, you can do that as well. Over here, we add 3. 5x equals negative 6. Divide by 5, we get x equals negative 6 over 5, or negative 1.2. So, for two fractions would be 12 fifths or negative 6 fifths. The decimals would be 2.4 or negative 1.2. Again, isolate the absolute value by itself first before you proceed. And we're going to cover one more problem here. And the problem is, this would be the most complicated problem we may see. Now, again, I need to get this by itself first. So I have something being multiplied and I have something being subtracted. Just like when we're solving equations, add opposites first. Now, 3, and this is times the absolute value of x plus 2 equals 9. Again, I need to get this by itself, so since it's being multiplied, I want to divide. Now, I have my absolute value all by itself. Absolute value of x plus 2 equals 3. Write your two equations now to solve. X plus 2 equals 3, and x plus 2 equals negative 3. Add negative 2. One answer is 1. Add negative 2, and the other answer is negative 5, and we have our two solutions. So this is the beginning of solving absolute value equations. We will continue with this a little further the next time.